So we're going to talk about a model for understanding gases, a theory. Kinetic molecular theory. So these words are descriptive. Kinetic refers to motion, and molecular refers to molecules. So this theory describes what gases do in terms of the motion of the molecules, how the molecules move. And it works really well for most conditions, but like any model, it'll break down under extremes. We're just going to look at where it does work, because we can. So this is what KMT, kinetic molecular theory, says. A gas is a collection of particles in constant motion. There are no attractions or repulsions between the particles. When those particles collide, they're like billiard balls and they just bounce off of each other and they don't lose any energy. There's a lot of space between the particles compared to the size of the particles themselves. And the speed of the particles is related to the temperature. If you increase the temperature, the particles move faster. So here's an illustration. I think of these as like marbles or airsoft pellets or something. Little tiny spherical objects, could be atoms, could be molecules, in a gas, and they're moving. Now, if you think about throwing a baseball, why does a baseball not just keep going? Gravity, right? Gravity is going to pull it down, and then there's also wind resistance that will slow it down, right? These particles are so small that gravity really doesn't have much of an impact on them. And is there any wind resistance for them? No, because they are the air. Yeah. I mean, because, when you fan something and you cause wind, you feel the breeze hitting your face, but you can't see it. What is it? Well, it's particles of gas hitting your face. It feels nice, right? And it slows you down because there's resistance. But these particles are the air. They don't have anything that slows them down. There's nothing smaller that is resisting them. They're going through nothing. So a gas particle set in motion will continue in a straight line until it runs into something. That could be a container. It could be your face. It could be the wall. It could be another gas particle. When it hits that something, it's going to bounce off without losing any energy and go in a different direction. And which direction it goes in, that's all physics. So they bounce off. There's no attraction between them. When they run into each other, they're not going to stop and chat. They're just going to bounce off. Okay? The faster they go, the warmer the substance. If you warm it up, they go faster. Because, well, I think we'll get to that. Any questions so far? So I'm not going to ask you to list the principles of kinetic molecular gas theory. Kinetic molecular theory of gases. I'm not actually even going to ask you to write the name because apparently I can't even say the name. Kinetic molecular theory of gases. You need to understand what it tells us about gases. So, kinetic molecular theory is consistent with the observed properties of gases. We know that gases can be compressed. You put a gas in a cylinder and press down on the piston, and you can squeeze the gas closer together. It will resist you, but you can squeeze it. You can't squeeze a liquid. Well, why is that? Well, there's empty space between the particles in a gas. So when you compress it, you're just pushing the particles closer together. You can't compress a liquid because they are already touchingly close. There's no empty space, really, that can be squeezed out. Gases take on the shape of their container. Liquids don't. Solids retain their shape. They don't even change shape when you put them in a different container. Liquids stay in the bottom of the container, but a gas will fill the container. And that's because the particles of the gases don't interact with each other. Why does water stay in the bottom of the cup? Why doesn't it fill the whole cup? Why doesn't it spread out? Because there's an attraction between the water molecules we talked about. They're very stuck on themselves. They're very attracted to each other, and they exclude things like oil. So they would rather be clumped together in the bottom of the cup than expand and fill the whole thing. Gas particles are not attracted to each other. They just go do their own thing. They travel in a straight line until they bump into something. So they fill up the container. Gases have low densities. A gas is much less dense. If you think about a balloon full of air weighs not very much at all. If you had the same size filled with water, it'd be pretty heavy. Water is more dense. Liquids are more dense than gases. And that's because gases have a lot of empty space. A lot of empty space. So here's an interesting idea. Again, the author is hung up on orange soda, right? So here, 1 can of soda. If you took the soda, the liquid in the can, and you converted it to a gas, that 1 can of liquid would fill 1,700 cans. Gases are much less dense, roughly 1,700 times less dense than liquids, because there's a lot of empty space, and empty space doesn't weigh anything.